Have you ever just looked out at the universe and really wondered, are its fundamental laws truly fixed, like set in stone? Or is there maybe something deeper, something more dynamic, almost like a symphony playing out?
Mm.
What if reality isn't just there, like a backdrop? What if it's actually constantly forming, constantly selecting itself moment by moment?
That's a fascinating thought experiment right there.
Well, welcome to the deep dive. Today we're taking a truly mind-bending journey, diving into a concept that doesn't just tweak physics, it seems to redefine the whole fabric of existence.
Yeah, it's pretty radical stuff.
We're looking at the work of Philip Lilien in his paper Eigenvalues, Eigenfields, and Hypersymmetric Emergence. It introduces this theory with a very grand name,
Oh, yeah.
the HHHCR-TOE. That's the hypersymmetry, hyperdimensional hyperspace, coherent resonance theory of everything.
Wow, okay. That is mouthful, but it hints at the scope, right?
Exactly.
Yeah.
It's a big one.
And look, this isn't just about, fiddling with equations and abstract math, although the math is definitely deep. It's a whole reinterpretation.
How so?
Well, familiar ideas like eigenvalues from, say, quantum mechanics or even basic linear algebra, they get promoted. They become the universe's fundamental resonance selectors.
Resonance selectors.
Oh.
Okay. What does that mean exactly?
It means they don't just describe things that happen. They actively mark the points where coherence, this sort of underlying connectedness, can actually become expressible, where symmetries break down into the forms we see.
So where particles and forces actually emerge.
Precisely. Where new particles, forces, structures pop into reality, it's a huge shift. We move from thinking of physics as fixed laws to seeing it as this dynamic emergent system that's constantly, tuning itself.
Tuning itself into existence. I like that.
Yeah, Lilien calls them ontological markers of resonance, symmetry, and emergence. Basically, the signposts pointing the way to reality itself.
Okay, let's really unpack this idea of eigenvalues then, because it seems absolutely central to Lilien's whole theory. Before we jump into, the really far-out stuff this implies, maybe let's just ground ourselves a bit.
Good idea. Start with the basics.
Yeah. For anyone listening who maybe vaguely remembers some linear algebra or even just physics class, what are eigenvalues and eigenvectors in that classical sense?
Right. So in basic linear algebra, you've got matrices, which represent transformations like stretching, rotating, shearing space.
Okay.
An eigenvector is a special vector. Let's call it V. When the matrix A acts on it, the vector doesn't change its direction. It just gets scaled, stretched, or shrunk by a certain amount.
Okay. It stays pointing the same way.
Exactly. And that scaling factor, that's the eigenvalue, usually written as lambda. So you get that famous equation,
Yeah.
A-fifths. It finds the sort of natural axes or invariant directions of the transformation.
Got it. So it highlights something stable within the change.
That's a great way to put it. And then this idea gets really powerful when you move into quantum mechanics.
How does it translate there?
Well, operators, which represent things you can measure like energy or momentum, they take the place of matrices. And wave functions, describing the state of a quantum system, they replace the vectors.
Okay, so similar structure, different players.
Right. So for instance, the Hamiltonian operator H represents the total energy. When it acts on a wave function, kex, it gives you an energy eigenvalue, E, so H. HX.
And that E is?
That E is a specific quantized energy level the system is allowed to have, like the energy levels of an electron in an atom. The tech is the state corresponding to that energy.
So it dictates the possibilities.
Exactly. The allowable energies, the stable states, it's fundamentally where the quantum system kind of resonates with its own structure. It reveals these specific stable configurations. Each eigenvalue marks a kind of resonance point.
Okay, so they show us these stable points, these natural resonances. But you mentioned Lilien's paper points out limitations here. What's missing from this classical or quantum view? What blind spots does this HHHCR-TOE aim to address?
Yeah, that's a really crucial point. Because while this eigenvalue framework is incredibly powerful for describing systems we already know exist.
Like atoms, yeah.
Right. It tends to assume those operators and structures are just given, predefined. It doesn't often delve into the deeper emergence of those structures themselves.
Meaning why they exist in the first place.
Exactly. Classical physics tells us the energy levels, but not fundamentally why atoms form with those specific levels, or why the Hamiltonian operator is what it is. It's like knowing the rules of chess, but not how the board or pieces came to be.
Okay. So it describes, but doesn't fully explain the origin.
Sort of, yeah. Lilien argues it's incomplete when you want to understand the origin and evolution of structure. It doesn't fully connect to what he calls coherence, which is
Right.
more than just waves in sync. It's like a generative field. And it doesn't fully integrate dynamic resonance fields or transitions between dimensions in the way he proposes. So the HHHCR2 wants to generalize this. Eigenvalues aren't just solutions. They're these fundamental thresholds in a resonance lattice of coherence.
The conditions that allow reality to crystallize?
Exactly. Crystallize out of pure potential. That's the idea.
Okay, here's where it gets really interesting, I think.
Yeah.
This is where Lilien's theory really starts to diverge. He shifts from eigenvectors to something called eigenfields.
Yeah, this is a big conceptual leap.
So what exactly is an eigenfield? And why is making this generalization so important? Does it change what we think the basic building blocks are?
Right. So an eigenfield is basically taking the eigenvector concept and stretching it out. Instead of a single vector pointing in one direction in space,
No.
think of a spatially extended structure, a field. Let's call it Chubecks. This whole field resonates with some operator O, such that...
About this. So the whole pattern stays the same, just gets scaled.
Essentially, yes. It represents an invariant resonant state across a region of space, maybe even time or other dimensions. Think about particle wave functions. Again, they aren't points, they're spread out fields.
Okay, yeah.
They are eigenfields of the Hamiltonian. Or, maybe a more visual example, the stable patterns on a vibrating drum head, or the standing waves on a guitar string.
Ah, the harmonics.
Exactly. Those physical patterns are eigenfields. They span the whole surface or length. This shift is huge because, well, most of reality, especially in quantum field theory or general relativity, isn't point-like. It's field-based.
Right, everything's a field, ultimately.
Lilien takes that very seriously. He's suggesting everything is fundamentally field-like, and these eigenfields are the stable forms those fields can take.
So it's not just a math solution on paper, it's a real physical structure. What's the deeper physical meaning here, beyond just describing something?
Exactly, it is the physical structure. In Lilien's coherence physics, eigenfields aren't just abstract solutions. He calls them coherence-bound structures. They literally are the stable, emergent shapes that reality takes.
Coherence-bound, meaning they're held together by this coherence field.
Precisely. An eigenfield becomes a mode of quantized coherence. And its eigenvalue tells you something about that mode, its strength, its stability, how strongly it's coupled to the underlying source.
And that source could be quantum fields, or this hypergravity thing.
Or infradimensional time, yeah. According to the theory, these eigenfields are the fundamental building blocks of the coherence lattice.
A coherence lattice, like an underlying grid.
Kind of, a dynamic network of resonance patterns.
Yeah.
And it's from this lattice that mass, forces, all structure basically crystallizes out of potential.
Wow.
Think of the universe as this vast, vibrating, coherent medium. The eigenfields are the stable patterns, the standing waves that can form. The eigenvalue tells you how strong or stable that pattern is.
So the quantum harmonic oscillator, that standard physics example.
Right, that's like an early glimpse of this. It shows how spatial structure, the shape of the wave functions, and energy quantization, the specific energy levels, are tied together through this eigenfield behavior. Each solution is an eigenfield.
So every stable structure is an eigenfield.
That's the core idea. The operator sets the context, the eigenvalue sets the specific resonance condition, and the eigenfield is the stable thing that appears. A universe built of resonant patterns, not tiny balls. And this leap from eigenvalues just describing things to eigenfields being things brings us right to the heart of Lilien's theory, the HHHCR TOE.
Right, the big one.
In this view, resonance isn't just something that happens sometimes within systems. It is the fundamental governing principle. It's how systems form, how they stick around, how they change.
An ontological principle, meaning it determines what can exist.
Exactly. Only structures that meet specific resonance conditions encoded in their eigenvalues can actually manifest. Everything else, it just stays potential, unstable, unrealized.
So if I'm getting this right, eigenvalues are basically the universe's selection mechanism, its way of filtering what gets to be real.
Precisely, you nailed it. They are the quantized thresholds, the points where resonance conditions click into place, allowing form to emerge.
Okay.
And Lilien introduces this idea of a coherence field, C. It's not passive, it's active generative. When it acts on some potential system, something, that eigenvalue is the key.
The coherence resonance eigenvalue.
Right. It determines if that eigenstate can actually stabilize and become real. It's like the universe tuning into specific frequencies. Coherence fields are the substrate, resonance is the selector.
That's a huge claim that all emergence, from particles to galaxies, is coherence quantization.
Can you give some more examples? How does this map onto physics we know?
Sure. We can actually map different areas. On quantum mechanics, the wave function is a quantum eigenfield. The energy E is its resonance mode in the quantum coherence field.
In field theory, any field, like electromagnetism, is an eigenfield. Its modes, like frequencies of light, are eigenvalues marking stable propagation.
Makes sense.
For the coherence field itself. Represented by a tensor, its eigenvalues measure how strongly it couples to other fields. For hypergravity, this isn't just normal gravity, it's a geometric distortion field. Its eigenvalues relate to curvature and mass, how gravity condenses things.
Wow.
For infradimensional time, we see harmonic oscillations. The eigenvalues are quantized temporal frequencies, creating rhythm, not smooth flow.
Rhythmic time.
And for dimensional scaling, it's about hyperfractal structures. Eigenvalues are scaling factors determining how dimensions nest and unfold.
Okay, so it's a pattern across different domains.
Yeah, they all show how potential crystallizes into structure, with eigenvalues as the universal markers selecting what stabilizes.
What's really mind-bending here, though, is that it's not just isolated systems. The theory emphasizes multi-domain interactions. How does that work? How do all these different resonances interact?
Yeah.
Sounds incredibly messy.
It is complex, yeah, but there's an elegance to it. It's all about interconnection. Fields don't just sit side by side, they resonate together. They form hybrid eigenvalue problems.
Hybrid problems.
Imagine the coherence operator, C, the hypergravity operator, Hg, and a quantum operator, Q, all acting on the same eigenfield.
Okay.
The result isn't three separate things. It yields a single unified coupling eigenvalue, C plus Hg plus Q. X, and that O is critical.
Why? What does it determine?
It dictates which combined resonance configurations are allowed across all those domains. It determines exactly which particles, forces, and masses can stably exist together. It's what Lilien calls the total interaction problem.
So putting it all together,
Yeah.
what does this mean for how we think about reality? What's the big picture shift?
It means reality isn't a static stage. It's fundamentally a coherence-tuned resonance spectrum. Eigenvalues are much more than math tools. They're the quantization of emergence, the universe's selectors.
And eigenfields are the results.
Eigenfields are the coherent expressions, the stable forms that resonance allows. It suggests this deep hierarchical nesting of structures, eigenfield resonance cascades.
Cascades, like Russian dolls.
Sort of. Lower order vibrations nested inside electrons, inside atoms, up to galaxies. Each level with its own eigenvalues, all modulated by coherence. Resonance isn't just an effect, it's the principle of ontological selection, how being arises.
The universe singing itself into existence.
That's a pretty good way to put it, yeah, with eigenvalues as the notes.
That foundation is. Wow. Okay, so now let's get into how fundamental things like mass, forces, even time itself supposedly emerge from this coherence framework. Lilien introduces hypersymmetry. What is that, and how do eigenvalues drive its breaking to create, well, everything?
Right, hypersymmetry. He defines it as this deep coherence algebraic unification of all the known symmetries, quantum Q, gravitational Hg, and his new coherent symmetry, C. They all combine into one operator, HSHU plus Hg plus C.
Okay, like a grand unified symmetry.
Exactly. And when this total operator acts on the state of the entire universe potential, X, it gives a single overarching hypersymmetry eigenvalue, S. This measures the total degree of universal coherence or symmetry.
So high ice means high symmetry.
Perfect symmetry, ideally. In a hypothetical ultimate state, OS would be at its absolute maximum, up max. The key idea is that any observable reality, any particle, force, structure only appears when this perfect symmetry is broken.
And symmetry breaking is?
It's not random. It's a controlled, predictable reduction in this eigenvalue.
A drop in the number.
Yeah. And the theory gives a really direct link between mass, m, and this eigenvalue. M is 0, 1, or a 1.
Whoa, okay. Let's break that down.
If S is maxed out, then that bracket term is 0. Mass S is 0, perfect symmetry, nothing has emerged yet, everything's massless.
Okay.
As us starts to decrease, moving away from a max, the term 1 us max becomes positive. Mass starts to appear. Symmetry is broken, distinct things can form.
And if S went all the way to 0?
That would mean maximal mass, or maybe total decoherence, a complete collapse of that initial symmetry. It fundamentally ties mass itself to the breaking of universal coherence.
So this sounds like a totally different way to explain mass compared to, say, the Higgs mechanism. Is it an alternative?
It's definitely presented as an alternative or perhaps a deeper generalization. It's a coherence field-driven mass generation process rooted in these symmetry eigenvalue dynamics.
How does it generalize Higgs?
Well, Higgs gives mass via interaction with a specific field. Here, mass emerges from the reduction of a universal symmetry, quantified by an eigenvalue. Plus, Lilien breaks down Lis into its parts. Lis equal Q plus log plus Lis.
Quantum gravitational coherence parts.
Right. And each part can change independently due to field interactions, coherence shifts, resonance gradients. This allows for really fine-grained modeling.
Like explaining why particles have the specific masses they do. The hierarchies.
Potentially, yes. It could explain mass hierarchies, maybe varying coupling constants, not just as numbers we measure, but as results of how symmetry breaks in these different domains.
So, if mass comes from these eigenvalue reductions, does that mean every layer of reality, from quantum foam up to galaxies, is basically an expression of a step down, a gradient in this eigenvalue?
Yes, precisely. Lilien actually states, every ontological layer is the expression of an eigenvalue gradient. Emergence isn't random, it's resonantly selected, structured by these symmetry eigenvalue drops.
A cascade.
Exactly. As drops from maximum pure potential, maybe quantum symmetry breaks first, particles emerge, then gravitational symmetry breaks, curvature inertia appear, then coherent symmetry breaks, stable structures form, like reality crystallizing out. And building right on that idea of eigenvalue gradients, here's another major innovation, maybe one of the most unifying parts. The theory claims all fundamental forces emerge directly from eigenvalue gradients.
All forces, just from gradients.
The force vector is literally defined as the negative gradient of the hypersymmetry eigenvalue. Just like gravity comes from gradients in potential energy, classically, here all forces come from gradients in this fundamental symmetry value.
Hold on. So you're saying gravity emerges from gradients in the gravitational part, lug, and electromagnetic force from gradients in the quantum part, lug.
That's the idea.
And then potentially new forces, these coherence-based forces, from gradients in the coherence part, lug C, that would simplify things massively.
Precisely right. It means all forces are unified under one metaforce law. All force is a resonance response to shifting symmetry eigenvalues. It swaps out our picture of four separate forces for one single coherence-based principle.
So electromagnetism, strong, weak forces,
Yeah.
they're all from IQ.
Essentially, yeah. Reflecting broken quantum symmetries, gravity from eggs showing hyperspace curvature, and maybe new forces related to entanglement, information, even biofields from AQ.
Wow.
It's a huge simplification. Forces aren't separate things, just different ways coherence dynamics manifest in different symmetry contexts. You could perfectly flatten those gradients, poof, no force.
Okay, this emergent idea keeps getting wilder. You're really telling me mass isn't some fixed intrinsic property. Like, it's not just part of what an electron is, it's an emergent resonance.
That's absolutely correct. And yeah, it's probably one of the biggest paradigm shifts in the HHHCR TOE. Mass isn't intrinsic, it's a resonant eigenvalue.
How does that work? There's this coherence coefficient, kick. How does that quantify this?
Right. Mass arises from the dynamic interplay between coherence fields, quantum structure, and hypergravity. The coherence coefficient is defined specifically as an eigenvalue of the coherence gravity interaction operator, say Shiji, acting on a field state, so Sicilian X.
And Akka measures.
It quantifies the coherence binding strength, how tightly bound, how stable, how coherent that field structure is. High Ak means strongly bound, very coherent, resistant to disruption.
And low Abir.
As ICOC nears zero, the field gets decoherent, massless, maybe entropic. It loses its structure. And here's the punchline. Mass-Go is defined as a direct function of this coefficient, where ICOC is some fundamental mass scale.
Like a maximum potential mass.
Sort of, yeah, a fundamental amplitude. And EDEC is a dimensionless factor, usually between 0 and 1, telling you how much of that potential mass is actually realized.
Okay, so how does this explain things we see?
Well, massless particles like photons. They naturally have EDEC equals 0. Pure coherence, no localized mass. Stable particles like electrons, they have a moderate ekek, reflecting their stable structure.
And heavy, unstable particles.
They'd have a high ekek, but their instability comes from the fragility of that high coherent state. It decays quickly. The whole particle mass spectrum maps directly onto a series of these coherence eigenvalues. Your body, your mass, is like a sustained, complex ripple of coherence.
That's incredible. If mass is tied to this resonance ladder of coherence collapse you mentioned, could that explain particle generations, electron, muon, tau, heavier copies?
Yes, absolutely. That's a great connection, and Lilien explicitly tackles that. The prediction is that generations correspond to quantized drops in AGIC.
So AGIC gets smaller for heavier generations.
Exactly. You'd have X generation 1, X generation 2, X generation 3. This perfectly explains the mass hierarchy. First gen, electrons, up-down quarks, have the highest EC, lowest mass, most stable.
And third gen, like the top quark.
Lowest EC for their family, highest mass, incredibly unstable. The hierarchy isn't arbitrary. It's a direct result of quantized steps down in coherence, that resonance ladder.
Wow.
And it also means stability and decay are governed by the stability of this eigenvalue. Decay isn't random. It's a resonance event, an eigenvalue bifurcation.
Oh, what?
Like the eigenvalue suddenly jumps down to a lower, more stable value, maybe due to some external coherence shift or internal wobble. It gives a deterministic reason for decay, rather than just probability. Even quantum uncertainty might have deeper coherence roots. And connecting this all up, maybe the most radical part. In HHHCR-TOE, time. It's not fundamental, not a continuous dimension like we usually think.
Not dimension. What is it then?
It's emergent. It arises from coherence modulation, structured by harmonic resonance eigenvalues. He calls it infradimensional time. It's layered, non-linear, tied directly to the fields, not a universal clock ticking away.
Okay, my head hurts a little.
Yeah.
So clocks, they don't measure some absolute flow. They measure these resonances unfolding. Does that mean time could be different for different things?
Precisely. You've got it. There's a harmonic resonance operator,
Okay.
H or R. It acts on a time-evolving eigenfield and gives a harmonic eigenvalue, Han,
Omega.
like frequency.
Exactly. Quantized frequency modes.
Yeah.
According to change it. Only the specific frequencies, specific rhythms, allow stable coherence evolution. This creates a complex temporal lattice of allowed beats, not a smooth line.
A temporal lattice. Okay.
Time progression isn't moving along a line. It's the phase evolution of a coherence eigenfield. Next. Each tick is tied to its eigenfrequency on. Higher on means faster phase evolution, a quicker beat for that system.
So different systems could experience time differently based on their coherence state, their un. That's the implication. Imagine a cosmic orchestra, each instrument playing its own quantized tempo. Our perceived time is just the dominant rhythm we're part of.
That is absolutely wild. So our experience of time, biological rhythms, they're not just arbitrary cycles, they're actual eigenstates in this temporal coherence frame.
Exactly. Because this infradimensional time is harmonic and quantized, any system governed by coherence, which is everything, according to Lilien, will show these temporal resonance zones.
Like circadian rhythms.
Yes, or neuron firing patterns, planetary orbits, even huge cosmic epochs like inflation or dark energy dominance. They're all seen as quantized eigenstates of infradimensional time.
Not just mechanical clockwork.
Right. A circadian rhythm might literally be a specific eigenvalue, say Euro, in a biological coherence field. It explains why certain rhythms are stable, why temporal coherence matters for memory or consciousness, why the universe unfolds in distinct eras. Each phase is a stable rhythm, an eigenmode.
Okay. What about the arrow of time? Why does it only seem to go one way?
Yeah. The model has a neat answer for that, too. Lilien suggests the arrow of time is a byproduct of phase decoherence in infradimensional resonance.
Decoherence, meaning loss of sync.
Exactly. When coherence breaks down in a system, when the phase relationships get scrambled, that's when time becomes directional. That's when entropy increases. The universe goes from higher coherence to lower, and that process is the arrow of time.
So time reversal would mean restoring coherence.
Essentially, yeah. Suppressing decoherence, retaining phase memory. It's not traveling back, but reversing the coherence dynamics. It ties coherence, entropy, and time's flow together intrinsically.
Okay, we've got emergent mass, forces, even time, all tied to eigenvalues and coherence. Now, what about the stage, the dimensions everything happens in? The theory talks about a hyperfractal manifold. That sounds complex. What does it mean for dimensions? Is this like string theory's hidden dimensions?
That's a good question, and no, it's quite different from standard compactified dimensions. In Lilien's view, the universe isn't a fixed 3 plus 1D box.
3 space 1 time, yeah.
Right. Instead, it's a dynamic hyperfractal coherence structure. Think of it as layered scale-sensitive field. And its dynamics are governed by fractal scaling eigenvalues.
Fractal scaling eigenvalues.
Yeah.
Okay, so dimensionality itself isn't fixed?
Exactly. It's resonantly selected based on coherence conditions. This hyperfractal manifold is like an underlying fabric with nested dimensional shells, each with its own resonance rules. It evolves through coherence cascades, not just spatial expansion. It's dynamic.
So if dimensions aren't fixed, how does this fractal scaling operator, F, describe this? What does its eigenvalue tell us about how dimensions pop up?
The operator F describes how a field behaves across these nested scales. When it acts on a field state, Fx equals Xx, that eigenvalue F is the fractal quantizer of dimensional emergence.
Beta, what does its value mean?
If white is a simple number, like 1, 2, or 3, it might correspond to the clear dimensions we see. If it's irrational, maybe fractal-like, it could suggest more complex, non-integer, or embedded dimensions like in chaotic systems. This leads to fractal eigenvalue cascades. Each step down might represent a new force appearing, or new particles, or a whole new layer of reality unfolding.
So the universe's structure is quantized dimensionally.
That's the idea. Not just energy, but dimensionality itself comes in steps defined by these vol values. Now, about those extra dimensions in string theory, the compactified ones. HHHCR TOE reinterprets them. They're not curled up small, they're hyperfractal coherence reductions. Effectively, losing a dimension corresponds to a drop in the coherence eigenvalue, d plus 1 phi d.
Ah, so a dimensional shift is linked to a coherent shift.
Exactly. And this explains why symmetries might appear or disappear, or why fundamental constants could change under different conditions. Lilien suggests the fine structure constant might emerge via fractal resonance at a specific threshold.
So fundamental constants, speed of light, Planck's constant g, they aren't just arbitrary numbers we measure. They're tied to this dimensional structure.
Yes, precisely the implication. They aren't universal presets. They emerge as fixed points, attractors, in the scaling eigenvalue spectrum of the hyperfractal manifold.
Attractors, like stable resonance points.
Exactly. He even suggests the fine structure constant, I1137, is a resonance fractional eigenvalue, possibly related to the golden ratio.
The golden ratio, wow.
Yeah, it suggests constants like C, G are emergent relations stabilized within the coherence field at specific dimensional layers, not fixed numbers. Each layer, defined by a baband, governs what physics happens there. Atoms, DNA, galaxies. He even maps BEBA1 to classical scales, BEF2 to biological scales, BAP2 to quantum zones.
A deep mathematical order linking dimension and reality.
So to formally describe how all these fields and dimensions interact, the theory introduces a really key object, the coherence tensor.
Oh, another tensor. Okay, how is this one different?
It's a big generalization. It represents the flow of coherence and information across the whole hyperfractal manifold. It generalizes spacetime's metric tensor from gravity and the stress-energy tensor from field dynamics.
It combines them.
It generalizes them, but critically adds structure. Resonance, coherence gradients, hyperfractal modulation across dimensions. Formally, it's defined using the coherence eigenfield, Kun. It measures field alignment, coherence density, phase concurrence. It's the blueprint of coherent structure.
That sounds incredibly powerful. So how does this tensor explain forces?
Yeah.
We said they were eigenvalue gradients before. Is there a link?
Absolutely. It all ties together. Forces emerge from gradients in the flow described by this tensor. Lilien defines a coherence curvature vector, φ2.
Okay.
This equation shows that electromagnetism, gravity, weak, strong forces, all of them boil down to differential coherence alignment across fields. Forces are about how the coherence field gets stressed or bent.
Like mass-bending space-time. But here it's bending coherence.
That's a good analogy, yeah. EM forces might be specific oscillations in the tensor. Gravity might be the overall curvature stress. It's a unified source for force. And what's really cool, tying back to mass itself can be localized and measured using the trace of this tensor.
Yeah.
Torsi.
The trace, sum of the diagonals.
Right. Lilien shows mass is proportional to it. High trace means a dense, coherent mass condensation point, like a particle.
And zero trace.
A massless field, like a photon. Pure coherence flow. A varying trace could even explain things like neutrino oscillations, where mass seems to change. Mass literally condenses from resonance tension in the coherence lattice.
Okay, and this tensor?
Yeah.
Does it lead to one unified equation for everything?
Right.
Replacing Maxwell's, Einstein's, all those separate ones?
That's the goal, yes. The
Yeah.
total interaction action in the theory combines quantum hypergravity grin and coherence tensors into one principle. S
Okay.
trinurance coefficient eigenvalue again. Exactly. When you extremize this action, the standard physics way to get equations of motion, you get unified field equations. It forms a coherent field dynamics framework.
Replacing all the old ones.
That's the ambition. And it can model extreme things like black holes or quantum decoherence, not as singularities, but as coherence collapse. Places where the tensor contracts sharply, mass diverges, time stops because the resonance patterns break down.
This brings us to the big one, the Holy Grail. If everything mass, time, dimensions, forces stems from coherence and eigenvalues, how does Lilien's theory actually unify all the fundamental forces? Does it give us a path?
It does, and it's a pretty radical path, different from usual unification attempts. HHHCR2 defines a single, overarching, unified coherence operator. U.
For unified.
Probably. It acts on all field modes at once.
U.
Here represents the combined state of all fields, and Hn is an eigenvalue tensor capturing the entire quantization structure of the universe.
An eigenvalue tensor.
And this equation isn't just a rule imposed from outside. It's a fundamental resonance constraint. It means the forms the universe takes particles, forces are selected only if they can stabilize coherence across all the symmetry layers. It's the master operator. Host, speaker. So, gravity, electromagnetism, strong, weak forces. They're not fundamentally separate. They're just different expressions, different facets of this single unified coherence operator. Precisely. That's the core implication. Each force emerges as a distinct symmetry resonant state of the overall coherence field. Think of it like different projections of U.
Projections?
Yeah, each projection corresponds to a specific symmetry topology within the field and has its own unique eigenvalue band within the bigger universal spectrum. Gravity relates to hyperfractal curvature, EM to U1 phase symmetry, weak force to SU2 chirality, strong force to SU3 color resonance.
All different eigenmode layers of the same underlying thing.
Exactly. They're all coherence stabilizers operating in different symmetry contexts,
Yeah.
all expressions of the same dynamics. And what's really compelling is the early universe implication. At extreme high coherence, right after the Big Bang perhaps, all these separate force eigenvalues would converge. Okay, at a single unified superresonant state. All forces were one because the operators were basically indistinct.
So unification isn't found by pushing current theories harder, but by tracing coherence back to the origin.
Exactly, back to the hyperfractal origin layer. And conversely, as the universe cooled and coherence dropped, fields split apart, forces broke away due to coherence resonance shell separation. Not spontaneous symmetry breaking in the usual sense, but a separation of these resonance bands.
Which would also affect the constants.
Right. Things like the fine structure constant, or G, are seen as coherence eigenvalue ratios, potentially emergent and variable depending on the coherence state.
Wow. We have covered an incredible amount of territory here. From basic eigenvalues up to this, frankly, staggering vision of a hyperfractal resonant universe where everything emerges. For you, what's the single biggest takeaway? What's the most profound shift this new ontology, this new way of seeing reality brings?
I think the biggest shift, the most profound thing, is that it moves physics from being purely descriptive or probabilistic to being inherently generative. It's not just how reality works, but how reality actually comes into being.
Generative.
The core idea is reality doesn't just exist. It emerges dynamically from coherence field resonance, physical quantities. They appear via structured eigenvalue selection. Forces, mass, particles, not fundamental bits, but stabilized resonance shells in the coherence field.
Dimension.
A hyperfractal resonance domain, not fixed. And constants, not given, but inherent coherent ratios within the field. It's physics explaining creation, not just describing the result. Lilien sums it up with his coherence principle of emergence. All structures, forces, and observables arise from coherence field configurations that stabilize into quantized eigenvalue forms.
That's quite a statement.
It really is. And its implications are huge. Emergence replaces randomness. Coherence replaces quantum collapse. Resonance replaces fundamental separation. It suggests a meta-framework that could potentially bridge physics, cosmology, biology, consciousness, self-organization, maybe even AI, a deeply interconnected, self-creating universe. Hashtag 4.2, testable predictions and technological directions.
Okay, it's a stunning vision, but it immediately makes you ask, how could we possibly test this? How do we apply these incredibly ambitious ideas? How does it get beyond just theory?
Yeah, that's always the million-dollar question for any grand theory, right?
Yeah.
But HHHCR2 does suggest some paths, ways to potentially validate it.
Like what?
Well, instead of just hunting for new particles, maybe we design experiments to look for subtle coherence eigenvalue thresholds. Like in ultra-precise atomic transitions, looking for tiny energy shifts not predicted by standard QM.
Hmm.
Or maybe analyzing synchronization patterns in neural networks, could they reveal underlying coherence principles? On a cosmic scale, maybe detailed gravitational lensing maps could show tiny anomalies hinting at hypergravity eigenvalues tweaking spacetime.
So shifting focus from measuring energy to measuring coherent states.
Essentially, yes, trying to detect these deeper resonance
That's
patterns.
really interesting. Are there potential practical applications down the line, maybe in energy or even AI, like you hinted?
Absolutely. Conceptually, it opens doors. If reality is resonant, maybe we can tap into it. Engineering resonance-based energy structures. Could zero-point energy extraction become feasible through coherence manipulation?
Whoa.
Lilien also mentions quantum biotronic control, maybe manipulating biological systems at a fundamental coherence level for healing or enhancement beyond just molecules.
Okay, that's sci-fi territory, but fascinating.
It is speculative, sure. Cosmologically, we could analyze cosmic structures like galaxies, not just as gravity clumps, but as hyperfractal resonance condensates. And yes, AI designing synthetic coherence architectures, what Lillian calls syntelligence.
Intelligence emerging from computational coherence fields.
That's the idea, a completely different paradigm from silicon logic. Long-term visions, definitely, but conceptually powerful. And really, all this work we've discussed, the Eigenvalues, Eigenfields, hypersymmetry, it's presented as a crucial piece of a much larger puzzle Lillian is building. He calls it the Unified Coherence Theory of Everything, or UCTE.
Even bigger.
Oh, yeah. The ambition is huge. It aims to truly integrate QFT, GR, dimensional emergence, but then go way beyond. It wants to bring in consciousness, observation, life, intelligence, self-organization, cosmology, all under one coherent framework.
Wow. All driven by coherence dynamics.
That's the vision. And this eigenvalue framework we've been discussing, it's presented as one of the formal cornerstones, the mathematical and ontological backbone needed for that kind of truly holistic science.
Well, to wrap things up, the paper ends with a really powerful, almost poetic line that seems to capture it all.
Ah, yes, he concludes. When the universe coheres, form arises. When form resonates, fields emerge. When fields stabilize, constants are born. This is not the end of physics, it is its awakening.
Chills. That really does sum it up. Moving from describing what is to understanding how it all comes into being through resonance. Hashtag outro. And that's our deep dive into Philip Lilien's truly groundbreaking vision of physics. It really makes you wonder, doesn't it? If everything we see, everything we are, is fundamentally a form of resonance, well, what signals are we still missing? What harmonies are playing out that we just don't hear yet? What if the universe isn't silent in those vast empty spaces? What if it's singing this incredibly complex symphony of coherence and we're only just starting to figure out how to listen? Definitely something to mull over.
Indeed.
Thank you so much for joining us on the Deep Dive. We hope this exploration into the HHHCR TOE has maybe sparked some new questions, given you some new ways to think about the very nature of reality. Until next time, keep exploring.